In this video, we're going to review how to evaluate a function at a particular value. As you recall, when looking at this function, which is read f of x equals x squared minus 2x plus 7, x is the independent variable. It is our input. So when we're going to evaluate this function at -5, then we're going to replace the independent variable, the input x, with -5. So we find the value of the function at x equals -5 by substitution. So we're going to evaluate f at -5, and where there's an x in our function equation, we're going to replace that x with the number -5. So instead of having x squared, we're going to write -5 squared minus 2 times x. So we're going to replace that x with a -5 plus 7. And now we're just going to do the arithmetic and simplify this expression. -5 times -5 is 25. -2 times -5 is plus 10, plus 7. 25 plus 10 plus 7 is 42. All right, what if we want to evaluate this function at some value other than just a constant, something other than a number? What if we want to evaluate this function at, let's say, -x? Is that a problem? Absolutely not. We can do that. We can replace the x in this function with anything we want to replace it with, anything. So how do I do that? Well, looking at this function, if I'm going to evaluate this function at -x, I'm going to replace all the x's in this function with a -x. So wherever there's an x, I'm going to replace it with -x. So what do I get? I'm going to get -x, and notice how I'm substituting that negative value into my function with parentheses around that. That's going to help me avoid making sign errors. I have -2 times -x, again, substituting that negative value into my function with parentheses, plus 7. All right, now what happens? Well, -x times -x gives me positive x squared. I have a minus, -2 minus x, that's going to give me a plus 2x plus 7. So f of -x is equal to x squared plus 2x plus 7. All right, what if I want to evaluate this function at, let's say, I don't know, x plus 5? Can I do that? Absolutely, I can do that. Again, how do I evaluate this function at x plus 5? Just like when we evaluated this function at -x, we're going to replace all the x's in our function with an x plus 5. All right, when we do that, what do we get? We get x plus 5 squared minus 2 times x plus 5 plus 7. Now we have to simplify this. X plus 5 squared, I'm going to square that binomial. I square the first term, I multiply the two terms together, and then double the result. 5 times 5 is 25. I'm going to distribute the -2 across the x, and the -2 across the 5, plus 7. Now we're going to combine like terms. I have an x squared. I have a 10x minus 2x. 10 minus 2 is 8x. Then I have a 25 minus 10, 15, plus 7 would be 22. So f of x plus 5 is equal to x squared plus 8x plus 22.